please. Okay, Desiree, can you give me the first step? Give me the quadratic formula, please.
So A is negative 5, B is
Yeah. Yeah, go ahead.
equals negative 30 plus or minus the square root of 30 squared minus 4 bracket negative 5 bracket 1.5. All over 2 bracket 1.
Excellent, very good. Okay. Isn't it nice? Like, think of 2 weeks ago when you learned this. Like, this is like the easy part of the question now. Like, doing something like that, and this is the nicest part. Imagine that. It's awesome. Okay, Noah, can you be human calculator? What's 30 squared, please? And negative 4 times negative 5 times 1.5.
What?
1.5. Should be on your paper, right? I think it's positive 30. Is it? Can you confirm it's positive?
Yeah.
Okay. Okay, so I'm going to write that as x equals negative 30 plus or minus the square root of 930 all over negative 10. All right, Alistair, can you do the square root of 930 for me, please, to 3 or 4 decimals?
30.49.
I'm assuming there's a lot more decimals after that. Such root plus. Okay, this is t not x, right? This is t equals, right? All right, Derek, what do we get to the left-hand side?
X equals 0.05.
A negative or positive? I think that's a negative, right? I think that one's a negative.
Oh, yeah.
And the right-hand side is?
X equals negative 6.05.
I think you got your pluses and minuses.
Yeah, I messed it
I
up.
think you got your pluses and minuses backwards there. Okay.
Wait, are we supposed to be rounding? Or
You want to keep it as accurate as possible. You as accurate as you can here. Okay. Now here's the thing. If I'm playing baseball, I don't know if you know this, but my nickname's Homer Simmons. Okay, it's not golf. Okay. But if I were hitting the ball, how many times is the ball going to hit the ground?
once?
Once, and that's it, right? I swing, hit the ball, it goes very, very far. Now hold on. Well, yes, it will take us. Okay, but here, this is the scenario that we're going to talk about here. For the person hitting the baseball, okay, here is the person right there, all right? So they swing and they hit the ball, and it's going to go something like this. Why is there a negative time in there? Now, this is a fundamentally very, very important thing. Why is negative time listed in there? What's that? No. It does hit it behind the plate, okay? If this problem were to continue, which it can't, okay, right? Again, basically the scenario is going to start with the ball already in the air and hitting the ground over here. If the time were to go backwards and continue on, mathematically it makes sense, but in real life it doesn't make sense, okay? So this is just a mathematical solution that we ignore. Okay, because what's the point? Because what I want to show you is that you're going to get two answers from this, but the negative answer doesn't make sense. Right, so this is 6.05 seconds here, and this is going to be negative 0.05. Right, but the negative answer you can't actually have, right? Because it's not possible to have negative time. So we're just going to say then, therefore, we will take.
So,
The quadratic formula, because we have to. Yeah, okay.
If you're really good at math in your head, you could play outfield, you could like, yeah, 6.5 seconds.
Oh, you totally could. You guys ever seen Iron Man? Anyone seen the movie Iron Man? The Avengers? Didn't you ever see his, like, like, they showed the inside of his helmet, and it's all math going all over the place. You ever see that video? No? But the first thing he's like, this is, okay, look, 285 meters here, 89 miles an hour, and all this. But no, and that's exactly, I mean, not as far as, when you're doing SBL, I don't think you're doing math in your head. But they say though, I read an article, this is me being a geek. I read an article about dogs using calculus. What calculus is, they talk about minimum distances. And a dog can, if you ever seen a dog, if you throw a ball to it, it's that in the water, they can minimize the time it takes them to get to the ball. They know they can run faster on the ground than they can in the water. Okay, so they'll want to find the least amount of time in the water and the most part on the ground. Dogs can do this in their head, calculus in their head automatically. Yes, okay, so I'm sure it works all the time for dogs, always. Okay. But as far as back to this question here though, we're going to ignore the point I wanted to get out of this is this solution we're going to ignore, okay? The negative time, generally negative time doesn't make sense for us. That's the point I wanted to make with that. Okay, we'll forget about the dogs optimizing their catching a ball time. Okay. All right, one last one for this. It's F. Am I going to do F?
No.
No, we'll stop. We'll do example 2. Let's do example 2 and then we'll stop. Okay? Example 2. What you guys going to do for me, okay? Here we go. Example 2 says Ava, which is my daughter, swings on a swing that is modeled by the parabola. H equals 4t squared minus 12t plus 10. A says, what is her initial height? B says, what is her height after 2 seconds? And C says, what is her minimum height? Yes, we probably should, although if you take a look, this is going to be very high swing. I feel sort of a bad parent if this is going to be meters. So we'll assume they're in Sadler's, we'll call it a new unit we're making up, which is nice to say for my sweet Ava, okay? So it'll be knee high, right? You can use meters in seconds. A 10 meter swing is dangerous, don't ever go into